Hi, my name is Nikira Washington, and today I just wanted to talk a little bit about Joe Boaler's book, What's Math Got to Do with It? And I think this is honestly a great book for parents, principals, teachers, really anyone who's into education or wants to know more about maybe how to get students or their children to love math more. So I think that Joe Boaler takes a very interesting math approach. She talks about how when we're doing math, we need to promote things like a growth mindset. She really produces collaborative work rather than sitting in silence or doing work individually. She also very believes in having students be given problems that are applicable to life in general. So she says that when we actually create environments where students are able to work together and solve really complex math problems and find their own ways and methods to solve the problem rather than giving them one method, students actually become very engaged, and it helps them in the long run with problem solving, critical thinking, and they become really great analyzers when it comes to getting problems. And I know, just speaking from experience, I think some of the most difficult math courses I have been in is where we're not allowed to talk to other students, we work independently, and there's only one way of doing things, versus some of the best math experiences that I have ever had were ones where I'm working with other students and I'm searching multiple ways, and we're able to verbalize how we got from point A to point B, right? And it's a really amazing process that happens. And I think that this book does a really amazing job of talking about how to do that. Joe Boaler gives so many amazing strategies to help your students or to help your children with math. I'm not going to give all of her, magic away, because I would really like for everybody to read the book or even look her up online. But I do want to talk a little bit about the 12 strategies that she gives at the end of the book that really just highlight how to, help students or to help your children with math, to encourage this mindset where math isn't such a scary thing. So the first strategy that she kind of suggests is that to never praise children by telling them they are smart. Instead, maybe saying something like, wow, I really liked how you worked through that problem. Could you show me again? That way they know their effort is being praised. I also know I try to change my language when I'm working with students to say like, wow, like I really liked the way you tried to solve that. You must be so proud. That way they understand that it is something that they should be proud of because they worked so hard to solve that problem. Another suggested strategy that Joe Boaler gives is to, and this is a really hard one, but never share math stories of math failure or even dislike. I think even when I was growing up, and maybe I would hear, friends or family friends say, I'm not really a math person, I don't really have a math identity, math's just not my thing. I think when I heard that, I was like, you know what? I feel that. I am not a math person either. But once this concept started to kind of marinate in my head, every time I was approached with math, I was in a fixed mindset to where I was like, well, I can't even approach or solve this problem because I don't, I'm not a math person. This wouldn't just happen in math courses, this happened outside the classroom as well. Anytime we're trying to calculate how to figure out, splitting money for, a restaurant or pizza, that would happen. So I think that's something that's super important. The fourth strategy that she suggests is that encourage students to work on problems that are challenging. And I think I really especially like this one because I think that, given anything, we're given a challenge when it comes to problem solving, it just causes us to find new methods. We have to look through certain things in order to figure out how are we going to do this. This is a new challenge for me, so I have to figure out how to get from point A to point B. And you're bound to make mistakes, which is actually her sixth point, is that you know, encourage mistakes actually, because when we make mistakes, our synapses are firing, we're learning more. And I don't know if anyone has seen the movie Meet the Robinsons, another great actually movie to show students, but there's actually a point in the movie where the protagonist is just sad because he invented something and it didn't work. But to his surprise, his whole family was so happy and super excited. They're like, "You failed!" And he was just confused. He's like, why are people, you know, celebrating my failure? And they explained to him that you can never succeed unless you fail. You know, you keep critiquing, you keep, you know, improving and revamping, you know, your process in order to make it better. So I just really loved that message ever since, and I think it's super important. Another thing she suggests is that encourage drawing whenever you can. I think that, you know, it really helps, especially since I think we're living in a world where visuals just really help us understand things. When students or children have visuals in front of them, it just helps the process a lot more. And 7 is encourage students to make sense of mathematics at all times. And basically what she means by that is to have a conversation about math. And she lists really great questions like, what is the question asking you? How can you draw this situation? How did you get that answer? It really allows you to reflect on problem solving just in general. And before you know it, when you're doing things from a day-to-day basis, you're realizing that I'm actually using math because I'm trying to figure out what this pattern is. I'm trying to figure out how to problem solve. And it really gets away from this idea that math is just rules and numbers, but more of a way of problem solving and understanding patterns. So I think that's a really great point that she brings up. She also encourages students to think flexibly about numbers, and this goes back to a point I made earlier. It's so great to encourage your students to find methods and to show different methods of how people will solve a problem. It allows them this flexibility, that way they don't feel like they have to just use one method all the time. Some methods might be easier for them to use. When students are working collaboratively and then it's like, hey, I solved mine this way, how do you solve yours? And they show them, that might be a way in which they're like, wow, I've never thought about that before, like, and that actually resonates and clicks with me a lot more than the method I was using before. So I think that's also awesome. This is a really big one, but never time children or encourage faster work. It's perfectly fine to be able to work through problems and to take your time. That's where a lot of cognitive work is going on, you know, and being able to think through this and to take the time to really sit down and problem solve and figure out like all the methods that you are using or to revamping is just so powerful. And in that aspect, again, you're learning, your synapses are firing, like I said, you know, you're allowed to make your mistakes, you're allowed to revamp, you know, but when you're pressured into getting something done at a certain time, like it just becomes very difficult. I think there's a lot of pressure then on students. They're more worried about the time rather than really sitting down and trying to understand and focus on the problem at hand. So number 10 is when children answer questions and get them wrong, try and find the logic in their answers, as they usually have used some logical thinking. And I think this is also very big and something I'm learning how to do myself when I'm working with children. I think that there's times when I'm working with students and maybe they'll get an answer for a problem that, you know, isn't the right answer, but I might ask, well, how did you get there? And once they show me, I can see, oh, okay, that's where I see that what you did there, you know. And it could be something as simple as like when, you know, they're multiplying, they might be accidentally adding, and I might say something like, you know what, like that's a great way to add, and you did a really great job. let me show you, or let me help you in regards to like multiplying. How might, you do A, B, and C in order to get D, so I think that it's super important to ask children how did they get there, because there was some thinking usually behind it. And last but not least is give children and students mathematical puzzles and play games. There are a lot of games that actually really promote mathematical thinking. Games that you wouldn't even maybe think, like Guess Who, that's great for logical thinking. Mancala, one of my personal favorites. Yahtzee, Mastermind, Blocus, Place Value Safari, and many more. And that just really gets students to really start to problem solve and have fun though too, and be engaged in these games. But yeah, these were probably one of like the best strategies that all these strategies were the best that Jill Boaler was able to give. But I really stress that throughout this book, her ways in which to take this new approach to math are super important, and she has had classrooms in which she's actually tried this approach, and students, it's amazing. Students' identities when it comes to math change enormously. They might be students who are like, I don't like math, I could never do this, to I love math. Like, throw any problem at me, I'll be ready, I can't wait to do this. And I really think that we all have an opportunity to make our children and students have the same engaging and life-changing experience when it comes to math. So thank you for watching.